Hello everyone, and thanks for tuning into the epic 9th Winter 2024-25 update from GavsWeatherVids. So here we go again. We've got a true epic for you this week. Well, every week we have an epic, but we've got a real epic this week. We're going to be bringing you all of the usual stuff that we would normally include in our winter updates. I'm going to be bringing you lots on the QVO as well. Now, sit back, relax, and enjoy, and I shall get on with the 9th Winter 2024-25 update in a moment. But just to say that first, a video series, our 6 AM UK weather forecast. We've also got a live stream coming up at 6 PM. We're going to be live this evening discussing this epic 9th winter update, doing a 10 to 14 there, and bringing you plenty of long range on that live stream as well. So please like, share, and subscribe on all of today's videos and content. I thank you so much, everybody, for doing that for GavsWeatherVids. Thank you so much, everyone. Thank you so much, Richard. Love it, love it, love it, love it, love it. Thanks so much to the amazing King of Swing, our swinger, Richard Shaw. Thank you so much, Rich, for swinging for us and for creating the winter updates gift here. Thank you so much, my friend, and thank you so much to Shryan Bruin as well. Hashtag Team Gav did an amazing job on the winter updates as always. Blimey, I don't know, do you? We're well over halfway mark now with our winter updates. Remember, each one of these winter updates is building up picture forensically until we get to the 1st of December, which is the day, but we are going to release the GavsWeatherVids Winter 2024-25 forecast. So that is going to be absolutely epic. And we've got just over, hold on. So sorry everyone, we've got just over a month to go on that. Well, anyway, let's not get ahead of ourselves. Still got plenty of winter updates to go at. And the first I'm going to look at for this 9th winter update, of course, it's got to be the swingometer. So the King of Swing has calculated all of the data up to the end of last week's 8th winter update. So after 8 winter updates, and at that point, 1 season model roundup, and of course the winter 24-25 NEO forecast that we released in the summer, this is how the swingometer is shaping up. In 5, in 4, in 3, in 2, in 1. Here we go, and the percentage is, yes, it is 60-40. 60% colder than average. So we actually saw last week a very, very slight swing back from mild to cold. Only a very tiny swing from mild to cold, but we did see a swing from mild to cold as of the end of last week's 8th winter update. So we're currently standing at 60-40 in favour of a colder than average winter. You're going to find out at the beginning of next week's 10th update how not only this 9th winter 2024-25 update affects the swingometer, but also the second seasonal model round. Because remember, everything goes into the swingometer, including the long range ones, including the NEO forecast that we start off with, and if that wasn't all of winter updates and downlogs, everything else as well. So you will find out next week how all of this weekend's data has affected the swingometer. But as of the end of last weekend, as of the end of the 8th winter update, 60-40 in favour of the colder than average winter. Thanks so much to Richard for our amazing swingometer there. Thank you so much to the King of Swing. Thanks so much, Rich. I love it. Love it, love it, love it, love it. Hope you're enjoying swinging, Miss Autumn, Rich. Right, well, let's move over to this page. This is coming from NASA, and we will begin the 9th winter update. So, this, as I say, is from NASA. And it is showing the levels of the atmosphere. So we've got the top top of the atmosphere in the stratosphere just here. That's 10 HPA. And then we've got the boundary level of the atmosphere that we call the troposphere. That is 30 to 50 HPA just there. And of course, we've been saying throughout this season of updates, we are well and truly into the westerly phase of quasi-biennial oscillation. So that sandy brown colour starting off at the top of the atmosphere in the stratosphere and descending down into the troposphere, that tells us that we currently have a mature westerly QBO, and we're going to keep a mature westerly QBO going throughout the winter of 2024-25. It will neither be ascending or descending. It will neither be descending or ascending. It will neither be waxing or waning. It will just be a mature westerly QBO. But we do actually probably see the first signs of the next ECQBO phase, just at the very, very top of the atmosphere, around 10 HPA. At the very top of the stratosphere at the moment. That is where the ECQBO will remain for the next several months, but by the time we get through the next spring, summer, we will see the next ECQBO phase do something a little bit like that. But for the winter 24-25, it's going to be a westerly QBO, and so for our analogues, I think so as a Shrine Brim sorting out our analogues for us, we're going to be looking at winters that are just mature westerly QBO winters. They're neither strengthening nor weakening, they're up their peak, and that's where we're expecting to be for 24-25. Right, so starting off with the first winter shrines picked out for us for a mature westerly QBO. It's 1957-1958 with a mid-Atlantic ridge and a trough of low over northern Europe. Winds coming in from more of a northerly direction. So that was a bit of a back low. Winds gets colder later through February and into March. Mild start. Then we've got 1959-1960. Another mature westerly QBO winter. This one is mild and unsettled. Low pressure in off the Atlantic. So we have a mild wet winter to start us off in the cold decade of the 1960s. We've got 1963-1964. Turning up next. This is just a dry winter, really. A high pressure dominator. One of those winters where we get like stationary high pressure, more or less over top of the country. Not particularly cold. That's a few cold snaps, of course, but not particularly cold for winter 63-64, and greatly overshadowed by the previous winter, which of course is the Daddy. By the way, somebody was saying in the comments on last week's winter update that they would like to see the Daddy. They wanted to show them the Daddy. 62-63, because we've only shown it once this season, and I'm so sorry, I've forgotten who that person's username was, but I think that person that commented, I kind of missed the point with this. We can only show the Daddy if the data allows us to show the Daddy. So, for example, if the QBO was in a similar phase, which I think for that winter was an easterly QBO winter. So if we had an easterly QBO winter, then we would be able to show the Daddy on this on this update. But because we're in a westerly QBO winter, we can't show you the Daddy. If you see what I mean. So you know, we can only we can't cherry pick data and just show the ones that the years that people want to see. They come out, you know, they come out of the woodwork. The Daddy comes out of the woodwork only if and when the data allows it. So we may see the Daddy again at some point through this season, or, you know, 62-63 might only be seen on that one update that we did a couple of weeks ago. I hope that explains that to anybody, you know, who's not familiar with what we're doing here at GavsWeatherVids. Right, let's carry on then. We're having a look at 1966-1967. Next, this is a relatively mild, mature westerly QBO winter with low pressure sitting over to the east coast, some higher pressure out to the Atlantic. A few cold snaps since 1960s winter, so there's a few cold snaps here and there, but overall, that's one of the milder winters for the 60s. We've got 1975-1976. This one is a dry and mild winter with high pressure in from the Atlantic, so it's in the middle of the drought years of middle of the 1970s, and that one's very mild and dry. We've got 82-83, our next mature westerly QBO winter. This one, the analog doesn't tell you a great deal about the winter, really. It has high pressure out here, low pressure up there. Generally mild and unsettled to start with, and then it gets a lot colder later. So it's a bit of a backloaded winter, and also has a very cold spring as well in 1983, which isn't really relevant for like a winter update, but it is of interest and of note. Right, let's carry on. They've got 1987, 1988. This is a mild and wet winter. Low pressure in from off the Atlantic. And they have quite a long gap, actually, to 2010, 2011. I think the reason for that is that, of course, there would have been westerly QBO winters through the 90s and 2000s, but those were either going to be sort of developing, strengthening westerly QBOs, or weakening, westerly QBO winters. So, but next time we have like a mature, and just a mature, strong West QBO winter is 2010, 2011. This, of course, for December to remember, with that big blocking area of high pressure towards Greenland, their pressure coming in from off the Atlantic. So it has the coldest December since 1890, the central England temperature. Copious amounts of snow. We're properly snowed up throughout December of 2010. Cold January, not as severe as December, of course. And then a very mild February. So that really is what we call a front-loaded winter cold weather in the front part of winter. And then we got 2015-16. So this one is exceptionally mild winter, one of the mildest winters on record. Also quite wet, low pressure in the Atlantic, bring the wind up southwest, and higher pressure is down here. And then finally, we've got 2022-2023. So this one has higher pressure throughout the North Atlantic into Europe as well. Rather a bizarre anomaly and analog. Does have some very cold weather in the early part of December of 2022. And then there's a few cold snaps in January and February of 2023 as well. Overall, slightly mild and average winter though. Right, let's put all that together then. So this is how all Decembers combined are looking following mature westerly QBO winters. Now, we do see, interestingly, a blocking signal in the North Atlantic, but it's slightly more over toward the Canadian side of Greenland, which means that overall probably favouring a rather mild and, and wet, unsettled December there. Exceptions, definitely. So there's 2010, which is the coldest December within the CET index back to 1890. Second coldest December within the entire CET index back to 1659. But overall, that's an exception overall. Most of those Decembers looking rather mild and wet. All Januaries combined look like that. Possibly a slightly better chance of a colder situation with the Januaries. Again, we see that high pressure in the North Atlantic, a little bit more centred toward the Canadian side of the green. Could be quite a cold signal for America, by the way, you'll notice. Low pressure looks like it's digging southwards into America, but again, not really relevant for us. However, we have got a trough over Scandinavia, so overall we might bring the wind in from the north. You kind of envisage certainly there'll be a chance of some colder snaps anyway within those Januaries. And then all Februaries combined look like that. Quite interesting. The higher pressure then perhaps coming a little bit more towards Greenland and Iceland with low pressure down here and jet stream down there as well. Could be a signal for some easterly outbreaks perhaps in those Februaries, and particularly so for more northern regions. And then all winters combined with mature westerly QBO winters. Actually, it's quite an interesting analogue. It's one of those that could go either way, really. So we do see quite a strong blocking signal with those red colours in the North Atlantic going up towards Greenland. And there's a fair amount of low pressure down here as well. Winds could be coming in from like an east or northeast direction, but could also be coming up from a southerly or a southwesterly direction. So not a great deal of help, I have to say. It's kind of 50-50 that, isn't it? Kind of 50-50 between, well, would it be a cold winter? Would it be a mild winter? Or would it be a mix? Maybe it would be a mix of colder interludes, but also quite a lot of milder weather. Now, one interesting factor about this westerly QPO, so it's also coinciding with solar maximum. There is a theory that if you have a westerly QBO coinciding with a solar maximum winter, then you perhaps have a slightly increased chance of a major southern stratospheric warming event occurring through the middle to latter part of the winter, sort of a late winter SSW type event. So I asked Ryan to have a quick look at this for us, and he created this very nice table here for us. So all of these winters that we see here from 2022, 2023, all the way down to 57, 58, all of these are westerly QBO winters. Most of them aren't relevant for where we currently are. So let's start getting rid of most of these. So, for example, we can get rid of that one because that's in the ascending phase of the solar cycles. Shrine has also put in the ENSO phase, well, very helpfully. That's solar minimum, so we can get rid of that one, and that's solar minimum 2, we can get rid of that one. That one is descending solar cycle phase, we can get rid of that one. That's descending solar cycle phase as well, so we can get rid of that one. This one, 2013, 2014 is around solar maximum, but it doesn't have the major SSW reversal, so we can get rid of that one as well. 2010, 2011, that's in the ascending phase of the solar cycle, so that one can go. 2008 and 9, that's around solar minimum, so that's not relevant right now either. 2006, 7. Remember, all of these are westerly QBO winds, so that's like the starting point of the research. That's in the descending phase of the solar cycle. This one's more relevant. This is 2001, 2002, which had an SSW, major SSW, reversal solar winds, 60 degrees north at 10 HPA in December of 2001. Was ENSO neutral, whereas now we're in a weak cladding year, and it was happening around solar maximum as well. So that's kind of a bit of a match for current scenario. That one can go because it's the ascending phase of the solar cycle. This one can go because it's the descending phase of the solar cycle. This one can also go because it's the descending phase of the solar cycle. 1991, 1992 is there as well, happening around solar maximum. That one is in an ENSO neutral phase, and it didn't have a major SSW with a reversal, though. It did have quite a significant SSW, but a significant minor SSW, but didn't have a reversal of solar winds. But 1991, possibly relevant. 87, 88, I think that was the with the Western QBO, with that was descending though, was weakening. Anyway, this ascending phase solar cycle, so that can go. That one is solar minimum. This one is in descending phase solar cycle. This one, 1980, 1981, is occurred around solar maximum. SSW there happens in March, though. So that's more for the spring, really, rather than the winter. And then we've got 78, 79, which is quite interesting. Westerly QBO winter with a major reversal of solar winds, major SSW reversal of solar winds, happening around solar maximum. So we have got that one in the mix as well. 75, 76 can go. 71, 72 can go. 76, 77 can go. 63, 64 can go. 61, 62 can go. Then we've got 59, 60 and 57, 58, which were not really relevant in terms of ENSO, but in terms of the solar maximum, they are a little bit more relevant. Both SSWs there happening in January. So how many matches does that leave us with? That leaves us with 1, with 2, with 3. Well, we take that one out, I think, because the SSW there happens in March, so we take that one out. 4. Again, that one does have a reversal of solar winds, but quite a significant SSW, 1990, 1991, and 5. So 5 matches back to 1950s in terms of a westerly QBO winter at solar maximum with a reversal of solar winds. So, it's of interest, it's of note, but I think the evidence there is rather patchy, to say the least, in terms of whether we do favour a mid to late winter SSW when we've got a westerly QBO scenario going on. There's a lot of variables that you've got to put into the mix with that. But it is of note, it's of interest. But this winter, as it's shown a maximum with Westerly QBO, it might favour later on, probably not early, but later on, it might favour a mid or late winter SSW with a reversal of zone of wind. It probably will be something that we'll have to keep an eye on as we go through this, through this winter. Thank you so much, Ryan, for sorting out that table for us. Thank you so much, Ryan. Thank you so much to Steffi Yakuk, actually was the person that pointed out that potential connection there. So thanks so much, Steffi, for pointing that out to me. That brings us very nicely on to, talking of SSWs and stratospheric scenarios, whatnot, that brings us very nicely on to the current situation at 10 HPA over the Arctic and over the North Pole. So this is how temperatures are currently looking, 10 HPA over the North Pole versus average. So the black line is like the current temperature, where the current temperature is at 10 HPA, and the grey line is the trend line. So we're actually a little bit colder than average now compared to, where you would expect us to be at this point in terms of temperature at 10 HPA over the North Pole. So we're just under minus 70, around minus 71, minus 72. We'd expect to be like somewhere around minus 68. So we're not greatly under average, but we are slightly colder than normal now. Temperature at 10 HPA over North Pole. Going a little bit low down to 30 HPA. There we can see that the black line is very much on trend. The temperature at that level of stratosphere remains very close to average. Let's have a look, shall we, at the latest GFS run, see how temperatures are expected to perform. So the blue colours here, that's the cold temperatures at their roots in the atmosphere and in the stratosphere at 10 HPA. You see that temperature around the North Pole is somewhere close to minus 72, as we have already established. A little bit colder than average. Right, let's run through and see what happens then. So, we keep a temperature around minus 70, minus 72, but for the next week. But then maybe cooling things a little bit more, actually. So, by early November, we're possibly going down to about minus 76, which I think will be quite significantly colder than average. We'll have a look in a moment. And then if we go even further on, again, we keep those temperatures around minus 76 into the extended range with the GFS as well. So let's go back to here, go back to 10 HPA. And so as we go into early November, we expect to be about where we are now, about minus 72. If we go down to minus 76, then we'll see the black line at that sort of level as we go into early November. So the black line possibly going to do something a bit like that, and it might actually be quite significantly colder than average, actually, as we get into the early part of November. Then we're looking for an SSW. A good example of that is what happened in 2013. This is from the archives at MetroSil. This is the stratospheric temperature at 10 HPA over the Arctic and North Pole on the 1st of January, New Year's Day 2013. See that dramatic red colour there? Well, it's yellow, orange and red, isn't it? With the core of the red just there. That is the sudden stratospheric warming that was taking place over Siberia on New Year's Day 2013. When we go through to the 5th of January, a few days further on, then check that out. Very dramatic developments with a strengthening of that SSW over Siberia, penetrating from Siberia into the Arctic and into the North Pole. A few days further on still, so the 8th of January, SSW has occurred. Zone of winds have gone into reverse at 10 HPA, 60 degrees north at this point. Notice that the colours are easing off, but we've got those yellow and orange colours moving into the North Pole. And notice how the polar vortex, these blue colours with cold temperatures at their roots, stratosphere being stretched to breaking point. We'll see what happens a few days further on. Check this out. And get a split of the polar vortex. So that SSW that we had in January 2013 did everything. Did absolutely everything. Reached the required temperature. It reversed the zone, reached the required temperature over Siberia and moved it into the North Pole. It reversed the zone of wind at 60 degrees north, so zone of winds went into reverse, and it also split the vortex in two. In fact, it didn't just split the vortex, it pretty much obliterated the vortex, to be honest. So, but we get through the 13th of January, check that out. Yeah, we've still got some legacy of the polar vortex, knocking around at 10 HPA, the stratosphere over North America and into the Atlantic and Europe. But basically, the polar vortex there has been pretty much obliterated at its roots. And it just went on, actually. That is like the 16th of January, and it just carried on. And so after that, we got like a strong blocking signal, or a strengthening blocking signal throughout the remainder of the winter. The winter got colder and colder and colder and colder and colder, culminating in the coldest March, I think, in the UK since 1883, I think, something like that. So, I mean, that's the kind of thing we're looking for. It doesn't happen every winter by any means. Let's have a look, shall we, at the next 6 weeks' worth of the temperature anomaly forecast for the ECMWF for 10 HPA, but change the scale with this. You remember last year I was saying we needed a new scale to be able to, take into account warmings that are going on, but perhaps not reaching sudden stratospheric warming levels. And whoever was watching the videos, I think you'll heard what we said, because we've now got a much better scale of the temperature anomalies there. Right, so this is week 1, going from the 28th of October to 4th of November. Blue colours, of course, are going to be cold temperature at their roots over the stratosphere and whatnot. When we go through to week 2, see the cold temperature expanding out. I've already seen that with the GFS, of course. Week 3, looking like that. It's the 11th to the 18th of November. Again, we see generally quite cold temperatures at 10 HPA, not the sign of warming. Week 4 looks like that. Week 5, again, everyone looks like that. And then week 6, which takes us from the 2nd to the 9th of December, looks like that. So up to week 6, no sign of any particular notable stratospheric warming going on. We do see a little bit of a minor warming taking place by them over Siberia, but of course that's 6 weeks away. It's a very, very long way out, and will therefore be pretty unreliable at that sort of time frame. Of course, SSWs get more likely further on you go into the winter, though, so we can have a look at some long-range forecasts for a bit of a QBO slash strat specialist, isn't it? QBO strat spec. We can have a look at some long-range forecasts. I mean, wasn't expecting this, was you, everybody? It wasn't expected to go as in depth as this. Never know what you're going to get with GavsWeatherVids updates. No, we can have a look at some long-range forecasts, though, for the zone wind. So we've looked at temperatures at 10 HPA. So far, temperatures and temperature anomalies. Another way of looking at polar vortexes through the zone of wind at 10 HPA. So this is the ECMWF seasonal forecast from Copernicus from November through to April. The important line here is the black line, because that is the seasonal average, if you like. And then the forecast lines, well, each individual line of spaghetti is like an ensemble member, but the key forecast lines are the blue and red lines just here. You see that the ECMWF is actually forecast zone of winds to be weaker than average through the core of the winter from December through to February. Perhaps gets a bit stronger. The forecast is for zone of winds to get a bit stronger later in the winter, but through the core of the winter, zone of winds a little bit weaker than average. This zero line here, any line of spaghetti that's under that is going to be an ensemble member that is going for an SSW. We do see a few of those, not many of them are outliers, but we do see a few of those through the middle of the winter. Right, so we can go on to Meteo France. Again, that one's showing the forecast lines be generally a little bit underneath the black line, underneath long-term average. So again, weaker than average zone of wind there through the core of winter, especially around sort of January time. DWD is a little bit more dramatic. So those first two are only very slightly under the black line. DWD is much more significantly under the black line there with the forecast ensemble mean and also the model climate mean. So they're both significantly underneath that black line. Again, though, not that many going for an SSW, but perhaps a few more into January and February with a reversal of zone winds. Where are we going next? That's DWD. Right, so we go to JMA. And that one, again, slightly under average with the forecast on top of email, the blue line, slightly under the black line as well. Most of these models appear to be going for like a weaker than average zone of wind through the core of winter, and that's the Met Office. And Met Office also going through the earlier part of the winter for a weaker than average zone of wind at 10 HPA 60 degrees north. Most of those models have like the forecast on top of being underneath the trend line, underneath climatology. So, you know, particularly for the earlier to middle part of winter, I think most of them then power things up a little bit later on in the winter. But for December, January, we might have a weaker than average zone of wind. Whether that indicates an increased chance of an SSW, though, or just a standard weaker than average zone of wind, you know, is food for thought and a little bit speculative, I guess. Right, well, what an interesting first half an hour. Blimey! Exciting, that wasn't it? If you've enjoyed the night winter update so far, please like, share, and subscribe. Thank you so much, everyone, for doing that. We'll have a little break there. When we come back, we're going to look at, we're going to go even further out. So we've got into strategy, we're going to go even further out into space. So we're going to have a look at solar data. So you stretch your legs, digest what you just witnessed. You witnessed a lot, I have to say. Packed a lot in there. But yeah, so when you come back, we're going to look at solar data, and I shall see you with that in about 2 seconds' time. See you soon, everyone. Okay, we're back and we're ready to resume the epic 9th winter 2024-25 update from GavsWeatherVids. If you've enjoyed what you've seen so far, please do like, share, subscribe, show everyone for doing that. Thank you to Richard and to Shryan for all of the help in the first half of the video. Absolutely amazing. Hashtag Team Gav doing an awesome job as always. But we're going to move on now and have a look at solar data. So this time solar disk is looking on our side of this day from solarham.net. We've got sunspots all over the solar disk, very spotty disk, and actually that nearly came out wrong, didn't it? No, and actually solar activity is at high levels when I'm recording the video on the 26th of October, as reported by Solarham. Is expected to remain at either high or moderate levels over the next 3 days. This began as well as night winter update solar activity tracker updated by Shryan. The orange lines and orange spots depicting each individual day's worth of sunspot activity. Notice the latest spot just here. That tells us that we are seeing an increase in sunspot and solar activity. We had our first peak of solar cycle 25. Maybe the peak of solar cycle 25, that's to be determined back in the summer. Then a bit of a drop down. Looks like we might now be starting to lift solar activity back up again a little bit. We'll be able to confirm that with the tracker next week. At the moment, the trend lines, which are the thick green and thick blue lines, doing something like that. So the thick green line, which is the 30-day average, is kind of flat, maybe ticking up slightly. The 60-day average is still like dropping a little bit. We'll be able to confirm next week whether that spot just there, that orange spot, whether that is a one-off or whether that's the start of solar activity, sunspot activity picking up again. This is from Rich. Thanks so much for Shryan for the tracker. This is from Rich saying spotless days and the current spotless stretch. So, of course, we have had 0 spotless days for 2024 so far. Every day has had sunspots, as we saw in 2023, and 2022 have 1 day without sunspots. Our comparable year from 24 is 2013, and that also had 0 days without sunspots. Loving the Halloween theme, by the way, Rich, on this solar gift, and also on the Swingo that started the video with. Loving the Halloween theme. Well done, my friend. Yes, so spotless days, no spotless days, as you expect, given that we are at solar maximum. We shall keep you informed on solar data for the remainder of winter updates. Arctic Station next. This is how the AO observed and forecast is looking. The black line shows where we've been, with the AO red lines at the end, with GFS doubles forecasted the AO to go. It has very, very strongly, intensely strongly positive Arctic Station conditions through the last week or so. Looks like we're on a downwards trend now, and as we go through the first half of November, we may see the Arctic Oscillation actually trending a little bit negative. Though that tells us, but as we go into November, we might be seeing signs of a northern blocking signal increasing a little bit over the Arctic North Pole. The LEO looks like it's also on move as well. We've had a very positive LEO also, but the GFS ensembles are forecasting the LEO possibly go into a weekly negative phase, certainly by the middle part of November. So with both the AO and the LEO trending perhaps into a negative phase for the first half of November, that might be a sign for some colder weather. What about the extended through the the early part of November? What about the Arctic Oscillation extended forecast from the CFS? This is from Kyle M. Critchie. So at the moment, of course, we have had that very positive AO coming down as we go into early November, and then generally the forecast of CFS is trending the Arctic Oscillation either neutral or negative, generally negative, and becoming more negative actually later on as we go out into January. So very negative AO being depicted there, telling us that the CFS is indicating quite a bit of blocking over the Arctic and North Pole through the middle part of this winter. The LEO doesn't look quite as dramatic, I have to say. So again, we're starting off, with that positive LEO going negative into early November, if the forecast is correct. Then around neutral through much of November before going weekly positive late November into December. And then just very close to neutral, really. So the LEO not going into a sustained negative phase, such as we see with the Arctic Oscillation. So if we have the LEO like neutral to positive, the AO just generally negative, that could tell us that we might get blocking this winter over the North Pole, but blocking might not be in a position to do, to be conducive to produce cold weather for our part of the world. But of course, most are very speculative extended range forecasts, so just keep an eye on how they develop. Oceans data next. So we saw Oceans looking with the last week's 8th winter update. These are our 4 interest areas. ENSO region just here, Northern and Northeast Pacific just there, Indian Ocean over here, and Northern Atlantic Ocean over there. That's how things were looking last week. Basically the latest. So I think we've seen a strengthening of La Nina through the ENSO region. I think all areas have actually seen a strengthening, a cooling, particularly in this central area actually, but also over towards the east as well. So La Nina has continued to strengthen a little bit. Still a weak event, but has continued to strengthen a little bit over the past week. What about into the Northern Pacific? That's the situation last week, that's the situation this week. So possibly, it is still colder than average up here in the Northeast Pacific, but possibly we're seeing that easing off a little bit, that cooling easing off a little bit over the past week. Into the Indian Ocean. Let's have a look. That's last week. This is this week. Most areas is generally above average. This cooler area just here has shrunk. And then into the North Atlantic. That situation, North Atlantic last week. This situation this week. Not much change actually there. Most areas still above average as always, particularly in the tropical, subtropical Atlantic, but also up here as well. This is how the 7-day trend, 7-day change is looking. So most areas in the ENSO region have seen some cooling actually over the past week. Northeastern Pacific generally cooling, but a little bit of warming took place just there. Indian Ocean generally warming up. North Atlantic Ocean cooling down just there, still warming a little bit through there. That's how the oceans changed in the past 7 days. Southern Oscillation Index, quite interesting. So remember, the SOI is measuring air pressures between Tahiti and Darwin, and then coming out with an overall SOI number that we get in this column. So when the SOI is negative, atmospheric setup will be reflective of El Nino. When the SOI is positive, atmospheric setup will be reflective of La Nina. So what's been going on through this season, of course, come down here. So we have had quite a lot of negative numbers telling us that the atmosphere has been kind of in an El Nino state a lot of the time. But over the past week, we might have seen a quite significant shift going on. So 19th of October, +4. 20th of October, +11 for the SY. 21st of October, +13. 22nd of October, +16. 23rd of October, +11. 24th of October, +16. 25th of October, +19. 26th of October, +13. Consistent positivity of the Southern Oscillation Index. That might be the atmosphere finally starting to couple up with the ocean, and that could explain why we've seen a strengthening of La Nina over the past week. The 30-day SY average, this red line just here, is lifting upwards. That's where it was about the 7th of October. This is where it is now. So, you know, it is definitely on the move a little bit. 30-day average, so it does move around quite a bit, but we might be seeing, you know, first signs of consistent positivity of a Southern Oscillation Index. If we are, then the SOI, you know, the La Nina will continue to develop through to the end of the year. Connected to sea surface temperatures, of course, is the 2024 Atlantic hurricane season. This is the 2024 Atlantic hurricane season page from Wikipedia. These are the scores on the doors. So we've had 15 total depressions, 15 tropical storms, 10 hurricanes and 4 major hurricanes. So tropical storms and hurricanes are up 1 on last week. Major hurricanes are unchanged. As far as ACE is concerned, this has been sent through by Ace Master Shrine Broom. Thank you so much to our Ace Master for updating this. Accumulated cyclone energy is telling us how much each individual storm, I should say, how much energy is depicting or giving out, and then creating an overall accumulated cyclone energy number for the season as a whole. So this is how ACE is looking for 2024. We're at 145.30. That is after 15 tropical storms, 10 hurricanes, and 4 majors. At this point in the season, we would expect to be at 113.00, so we're above average for accumulated cyclone energy for this season. That will be after 13 tropical storms, 6 hurricanes, and 3 majors. So all the numbers are now above average for this season, and we have actually reached where we was in 2023 for accumulated cyclone energy for the season as a whole. So 2023, the season came out at 145.60, so we've basically matched that, and there's still like another month of the hurricane season to go. Could we get hyperactive? I reckon we probably need to put on about another 30-40 points to get to a hyperactive hurricane season. So I guess basically one more major hurricane would probably get us there, but it's late on in the season. We'll wait and see what happens. Okay, well, we're going to have another quick break then, and when we come back, we're going to go through Eurasian snow cover for the climax of this epic night winter update. I hope you enjoyed it so far. A little bit more to show you, and then we'll get it all wrapped up for you. But again, you go off and stretch your legs, and we'll see you with more in about 2 seconds. Okay, we're back and we're ready to resume and climax on this epic 9th winter 2024-25 update. If you've enjoyed what you've seen so far, please like, share, subscribe, tell your friends, tell your family, tell everybody about the unique content that we're producing at GavsWeatherVids. I mean, thank you so much, everyone, for doing that. Thank you so much, everyone. Thank you to Richard, Alice Ryan, hashtag Team Gav, for all of the help on this epic 9th winter update. Amazing work, guys. Thank you so much. Right, okay, well, let's do this then. Final section. You'll look at Eurasian snow cover. That is how Eurasian snow cover, including Scandinavian and or Nordic snow cover, was looking where we did last week's update. So this is the latest, 5, 4, 3, 2, 1, here we go. So as of the 25th of October, that's how we're looking. So we have seen gains in snow cover across Russian Siberia, but the snow line has not advanced any further westwards. The snow line is there, and that's roughly where it was last week. However, this area has filled up further with snow. So we have seen gains over the past week in terms of the eastern portion of Siberia, but we haven't extended the snow line any further westwards. As far as Scandinavian Nordic snow cover is concerned, probably lost a little bit there, actually, and doing pretty poorly, I think. But let's have a look and see how we compare back to 1998 to all other years. So here we go, Ben. We are behind 2023 for Scandinavia. I'm going to say, when I say Scandinavian, please bear in mind that includes Nordic snow cover as well. So when I say Scandinavian, that'll be including this whole area here. I haven't got time to say Scandinavian and Nordic on every year. So Scandinavian snow cover will include Nordic as well, if that's all right with everyone. So we are behind Scandinavian snow cover in 2023 this year, and we are behind 2023 for Siberian snow cover as well at this point. That is 2022. So we are behind 2022 for Siberian and Scandinavian snow cover. We are behind 2021 for Siberian and Scandinavian snow cover. And we are behind 2020 for Siberian and Scandinavian snow cover. We're behind 2019 for Siberian and Scandinavian snow cover. We are behind 2018 for Siberian and Scandinavian snow cover. And we're behind 2017 as well for Siberian and Scandinavian snow cover. Oh dear, we're not doing so good, are we? That's 2016. We're behind 2016 for Siberian snow cover. Probably not that far away, Scandinavian snow cover. That's 2015. We're behind 2015 for Siberian snow cover. Probably quite close for Scandinavian snow cover. That's 2014. We're behind 2014 in all areas, and very substantially so as well. That is 2013. We're behind 2013 as well in all areas. That is 2012. We are now behind 2012 for both Siberian and Scandinavian snow cover. Oh dear, that's 2011. So we're probably quite close to 2011 for Siberian snow cover. But I think the snow line is a little bit further westwards in 2011 than it is this year, and probably quite close to Scandinavian snow cover as well. That could be one of the closer matches. That's 2010. So I think we're close to 2010 for the snow line here, but we are behind it for Scandinavian snow cover and into northwest Russia as well, basically behind 2010. That's 2009, so we're behind 2009 for Scandinavian and also Siberian snow cover. That is 2008, so that could be a closer match. I think that's perhaps the closest match that we've seen so far in terms of where the snow line is, and Scandinavia / Nordic as well. So let me know in the comments which years you think we are closest to, please, everyone. If you could do that, let me know, that'd be absolutely awesome. That is 2007, so that could be a closer match as well. That's 2006, we're behind 2006, substantially so, for both Siberian and Scandinavian snow cover. That is 2005, that could be a closer match for Siberian snow cover, but we're behind it. Scandinavian snow cover, that is 2004. Oh, we're behind 2004 for Siberian snow cover, Russian snow cover, but probably a little bit behind for Scandinavian snow cover as well, not greatly so though. That's 2003, behind 2003 in all areas. That's 2002. We are behind 2002 in all areas as well. That's 2001, behind 2001 in all areas. That is 2000. That could be a closer match. That could be the closest match, actually. Again, please let me know which years you think we're closest to everyone. I think 2000 might be closest match for both Scandinavian and /Nordic, and also Russian Siberian snow cover. That is 1999, so I think we're a bit behind 1999 in all areas, and that's 1998. That could be a close match for Siberian snow cover, but we're behind for Scandinavia and Nordic snow cover. So we really haven't done very well over the past week. Seen a definite stall of advancing the snow line from east to west across Russia, and looking really quite poor across Scandinavia as well. Let's go through to 1966 with Rutger Snow Lab. Now, I won't do a year-by-year comparison. I haven't got time to do that, but just keep this in mind, you know, where the snow line is and what it looks like over Scandinavia. Okay, and we'll go through it then. So I think we're behind 1997 for in all areas. We're behind 1997 in all areas there. We're behind 1996 for Scandinavian snow cover. Probably quite closely matched those for Russian Siberian snow cover. We're behind 1995 in all areas. Probably quite close to 1994. Scandinavian snow cover could be a bit ahead for Russian snow cover. That's one of the few years it might be ahead of. 1993, we're behind in all areas. 1992, I think we're also behind in all areas. 1991, could be a bit ahead of that year for Russian snow cover. And also Scandinavian snow cover, that might be close to match. 1990, we are probably a little bit ahead for Scandinavian snow cover, given it doesn't look like there's any snow cover across Scandinavian Nordic regions there, but behind for Russian snow cover. So 1990 is a strange one. 1989, I think we're behind that year in all areas. We're ahead of 1998 for both Russian, Scandinavian and Nordic snow cover, definitely, and we're ahead of 1988 and ahead of 1987 as well. 1986, what do you think about that one? So I think we're behind 1986 in both areas. In 1985, we're behind that one for Russian snow cover, probably quite close. Scandinavian snow cover. 1984, probably a bit behind that year as well. 1983 could be quite close match to this year for Russian snow cover, behind it for Scandinavian snow cover, Nordic snow cover. 1982, we're behind that year, I think. 1981, that could be a closer match for where the snow line is, couldn't it? Probably quite close for Scandinavian snow cover as well, so that could be a closer match too. We're ahead of 1980 for Scandinavian and also Nordic and also Russian Siberian snow cover. 1979, I think we're a bit behind that year. We are way behind 1978, not where the snow line was in 1978. Most of, certainly Siberia, and a good portion of Russia filled up with snow, and a lot of Scandinavia filled up with snow as well. So way behind 1978. Good gracious me, we're behind 1977. Look at 1976. The snow line actually got to virtually the steppes of Europe at this point in 1976. Most of Scandinavia, Nordic regions covered as well. So obviously we are way behind, no comparison to 1976. 1975, we could be ahead of that year for Russian snow cover, behind Scandinavian snow cover. We're behind 1974. 1973, we're behind that year for Scandinavian snow cover, could be a little bit ahead for Russian snow cover. 1972, behind that area, but we're behind that year in all areas. 1971, behind that year. 1970, we're behind that year. No data for 1969. 1968, we're behind that year in all areas too. 1967, we're behind that year, and we're behind 1966 as well. So, I mean, we've not done very good over the past week, but maybe this next week we'll see a significant expansion. Put your teeth in, gather snow across Russia and something happening over Scandinavia. We shall update you, of course, next week. Right, well, that brings to a close, and that brings to a climax your epic Night Winter update. Catch it under the hour as well. So I thought this one we might be pushing the hour mark, especially when I saw that like the first section had been a half an hour section. I thought, ooh, maybe we're going to push the hour on this one. But we're underneath the hour again. So I think that's pretty good going to get through all of that. Again, everybody, please let me know which shoes you think we're closest to in terms of you know, bestow cover there. If you could do that in the comments, that'd be absolutely awesome. Right, so that's the end of the 9th winter update. You'll find out at the beginning of next week's 10th winter update how all of this has affected the striometer, if indeed it has. That'll be the first thing that you'll see on next week's 10th winter update. Thanks you so to Shryan Bruin, and thanks you to Richard Trott for all of the help on this winter update. Been absolutely epic. Thank you so much. Hashtag Team Gav as always. Awesome job, guys. And don't forget to be live at 6 p.m. We're going to be discussing this 9th winter update, doing 10 to 14 day, and bringing you some long range on that live stream as well. And that'll be coming up from 6 p.m. this evening. But for the 9th winter 2024-25 update, that's all for now. So much for watching, and at 54 minutes we'll end it there. Thanks so much for watching. See you next week with the next installment. Bye for now.